Welcome to my channel Mathematical Clinic of Subhash Jha. We are in the fourth lecture of permutation and combination. Today we are going to discuss the word factorial. Factorial. Actually, factorial of number 2 is denoted by like this or by this, and it is the product of 2 and 1. Factorial of number 3 is denoted by factorial 3 like this or like this, and this is defined as 3 into 2 into 1. This one is 2, this one is 6. Likewise, factorial 4 becomes 4 into 3 into 2 into 1. This one is 4 3 is 12 to 24. Factorial 5 is 5 into 4 into 3 into 2 into 1. This one is 5 4 20, 3 60 to 120. So in general we can say that factorial of any positive integer is the continuous product from that integer up to 1. Factorial 5 is the continuous product from 5 up to 1. Factorial 4 is continuous product from 4 up to 1, 4 into 3 into 2 into 1. Likewise, factorial 7 is 7 multiply 6 multiply 5 multiply 4 multiply 3 multiply 2 multiply 1. It means the continuous product from that positive integer up to 1. In another sense, we can say that we can see here factorial 5 is 120 and factorial 4 is 24. How can this 24 be obtained from 120? If you divide 120 by this number 5, what happens? 120 divided by 5 equal to 5 to the 10, 25 for the 20. Exactly this number 24 will come. So to get factorial 4, the value of factorial 4, we multiply the value of factorial 5 by that 5 1. To get this one, we divide this 24 by this 4 1. To get this one, we divide this 6 by this 1. So by this manner, what will be the value of factorial 1? Factorial 1 will be, you divide this 2 by this number 1. 2 upon 2 equal to how much? 1. By that manner, what will be the value of factorial 0? You divide this result by this number 1. It will be 1 upon 1 equal to how much? 1 upon 1 equal to 1. So factorial 0 equal to 1. By the same manner, what will be the value of factorial minus 1? Value of factorial minus 1 will be, you divide this result by this number 1. 1 upon 0 equal to infinity. Again, what will be the value of factorial minus 2? Factorial minus 2 will be, you divide this number by this result 1. Infinity divided by minus 1 equal to how much? Infinity. Once again from the beginning, value of factorial 5 is, you multiply 5, 4, 3, 2 and 1 to get the value of factorial 5. It is 120. Value of factorial 4 by the same manner becomes 24. Value of factorial 3 becomes 6. Value of factorial 2 becomes 2. Value of factorial 1 is 1. Actually, we are able to see here that this number, it means the value of factorial 4 can be obtained by dividing this result by this number 1. If you divide 120 by 5, then the result will be 24. That is the value of factorial 4. By the similar manner, if you divide 24 by this 4 1, then the value of factorial 3 will come. 24 upon 4 equal to 6. Likewise, if you divide this 6 by this number 1, then you will get the value of factorial 2. So if you follow this process 1, then what will be the value of factorial 0? You will have to divide this result by this number 1. If you divide 1 by 1, then the result is 1. And again, what will be the value of factorial minus 1? You divide this result by this number 1, this 0 1. 1 upon 0 becomes how much? Infinity. That is why we come to the conclusion that the factorial 0 is 1 and factorial of any negative integer is infinity. Now I am going to summarize it. We can define factorial if n is any integer, then This factorial n, you can also denote by this, can be defined in three domains. If n is negative integer, any negative integer, then the value is how much? Negative integer, then the value of factorial n is infinity. If n is 0, then value of factorial n, if n is 0, then value of factorial n is 1. And if n is positive integer, then its factorial is n into n minus 1 into n minus 2, continuous product up to 1. Continuous product up to 1. This one is the definition of the factorial. Once again, the value of factorial n is defined in three domains. If n is negative integer, then value of factorial n is infinity. It means the factorial of any negative integer is infinity. The factorial of 0 is 1. And if n is the positive integer 1, then its factorial is the continuous product of n continuously up to 1. N into n minus 1, n minus 2, continuously up to 1. Product of all those positive integers is defined as factorial n. Now we are going to write some important remarks from here. Especially for positive integers, n factorial is just defined as n into n minus 1 into n minus 2 up to 1. If you separate n, if you write n all separately, then what are you left with? This term can be said as this has started from n minus 1 and ended with one continuous product from n minus 1 up to 1, so it can be defined as n minus 1 factorial, written as n minus 1 factorial. That is why, if needed, n factorial can be written as n multiply n minus 1 factorial. Even if you separate these two integers n and n minus 1, then what are you left with? You are left with continuous product from n minus 2 up to 1, that can be written as n minus 2 factorial. So we came to the conclusion that if needed, n factorial can be written as n into n minus 1 factorial, even n into n minus 1 into n minus 2 factorial. By the same manner, we can also write n into n minus 1 into n minus 2 multiply n minus 3 factorial, and so on. We can extend this one by this particular logic one. So n factorial equal to, this one is the definition, if n is the positive integer, and it can be also written as n into n minus 1 factorial, n into n minus 1 into n minus 2 factorial, n into n minus 1 into n minus 2 into n minus 3 factorial, and so on. Again, don't forget, factorial 0 is how much? 1. And factorial of negative integer is always infinity. Now some factorials. The first numerical one is, example number 1 is, find the value of 20 factorial plus 19 factorial divided by 20 factorial minus 19 factorial. Everyone concentrate here. Actually, I am going to make the factorial terms same in each terms, first, second, third and fourth one. By the last remark one, can 20 factorial be written as 20 multiply 19 factorial? Of course, this 19 factorial as it is. Downwards also, this 20 factorial can be written as 20 multiply 19 factorial, and this 19 factorial as it is. Let us take 19 factorial common from the numerators. 19 factorial common, then you are left with 20 plus 1. And if you do same in the denominator, take 19 factorial common, then you are left with 20 minus 1. This will be cancelled, so result will be 20 plus 1 equal to 21 divided by 20 minus 1 equal to 19. That's the answer. One another example. For example, the question may be, find the value of x if 1 by 9 factorial plus 1 by 10 factorial equal to x by 11 factorial. This type of question may be there. Here also, because they are continuous 9, 10 and 11, Better we make all factorial terms 11's factorial. How can you do so? You can simply think here, it is 9 factorial. If you multiply this 9 factorial by 10, then it will be 10 factorial, and even by 11, then it will be 11 factorial. So to make this 9 factorial as the 11 factorial, I have multiplied the denominator by 10 multiply 11. To balance it, we will have to multiply the numerator also by 10 multiply 11. Do same here. Here you are given with 10 factorial. To make it 11 factorial, what should be done? You multiply by 11. So to balance it, you also multiply the numerator by 11, and this one is x upon 11's factorial as it is. This is 10 11s are 100, 10 divided by this can be written as 11 factorial, plus this one is also 11 by 11 factorial equal to x upon 11 factorial. 11 factorial from this side will be cancelled, and here you are left with x equal to 110 plus 11 equal to 121. That is the answer.